Why does one variable disappear after a function ends while another stays alive throughout the entire program? And why does Python sometimes find a variable instantly but other times it keeps searching somewhere else? Today you'll finally understand the reason. Hello everyone, welcome back to our Python functions series. In the previous video, we learned about global variables and the global keyword. Today we are going one step deeper to understand how Python manages variables behind the scenes. Once you understand today's concepts, many confusing Python programs will suddenly start making sense. We learn three important concepts with simple examples and practical programs. Let's begin with variable lifetime. Think about this. When you create a variable inside a function, does it stay in memory forever, or does Python remove it after the function finishes? Let's find out. The lifetime of a variable means how long that variable exists in the computer's memory during program execution. Different variables have different lifetime depending on where they are created. Let's see what happens with a local variable. Here, message is created when the function starts executing. Python stores it in memory. The function prints it, then the function finishes. At that moment, Python removes the local variable from memory because it is no longer needed. So every time the function runs, Python creates a fresh local variable. And after the function finishes, that variable is destroyed. Let's see one practical demonstration. Did Python reuse the previous variable? No. During the first function call, Python created a local variable named number. After the function finished, it was removed from memory. When the function was called again, Python created a completely new local variable with the same name. Although the name is the same, it is a fresh variable created for the second function call. Now let's compare this with a global variable. Name is created outside the function, so it is a global variable. Unlike local variables, Python doesn't destroy it after the function finishes. It remains in memory until the program ends. That's why both the function and the main program can access the same variable. Remember this simple trick. Think of a classroom. A local variable is like a notebook given to a student only during one class period. Once the class ends, the notebook is collected back. So the difference between local variable and global variable is created when function starts. Global variable created when program reaches it. Local variable destroyed after function ends. Global variable exists until the program ends. Local variable exists temporarily and global variable exists throughout the program. So far, we learned how long variables live. Let's answer another important question. Suppose your program contains multiple variables with the same name. When Python sees that variable, how does it decide which one to use? Does it randomly choose one? No. Python follows a fixed searching order called the LEGB rule. LEGB stands for L local, E for enclosing, G global, B built-in. Whenever Python needs the value of a variable, it searches in this exact order. If Python finds the variable at any step, it immediately stops searching. Let's understand these one by one. First is local scope, L. Python always checks the local scope first. Local means variables created inside the current function. For example, let's understand this. There are two variables named x. One is global with the value 100, another is local with the value 20. When Python executes print x inside the function, it first searches the local scope. It immediately finds the local variable with value 20, so it stops searching. The global variable is completely ignored. Now let's understand the enclosing scope. This exists only when one function is defined inside another function. Such functions are called nested functions. Let's understand with the help of one example. Inner function doesn't have a variable named message. So Python searches the enclosing scope, which is the surrounding outer function. There it finds a variable and prints hello Python. One more example of enclosing scope. Python first checks the local scope of inner. No variable is found. Next, it checks the enclosing scope. There it finds x is equal to enclosing. So Python prints enclosing. What if Python doesn't find the variable in either the local or enclosing scope? Then it checks the global scope. Let us understand with the help of one example. There is no local variable. There is no enclosing function. So Python checks the global scope. It finds x and prints 500. What if Python still cannot find the variable? Then it checks the built-in scope. The built-in scope contains functions already provided by Python. Len function is not defined anywhere in our program. Python automatically finds it in the built-in scope. Let's take another example. Max is also a built-in function. That's why we can use it directly. Let's take one real-life analogy. Imagine you're looking for your house keys. First, you check your own pocket. That's the local scope. If you don't find them, you ask your family members. That's the enclosing scope. Still not found, you search the entire house. That's the global scope. Finally, if they are nowhere in the house, you check the building's lost and found office. That's the built-in scope. Python follows a similar step-by-step search process. So far, we have learned how long variables live and how Python searches for variables. Now let's understand one of the most misunderstood concepts in Python. When we pass a variable to a function, is Python passing the variable itself or a copy of it? The answer is neither. Python follows a concept called pass by object reference. In Python, variables do not directly store values. Instead, they refer to objects stored in memory. When we pass a variable to a function, Python passes the reference to that object, not the variable itself. Let's first see what happens with an integer. Initially, number refers to the integer 50. When we call the function, the parameter num also refers to 50. But inside the function, we write num is equal to 100. Python creates a new integer object with the value 100 and makes num refer to it. The original variable number still refers to 50. So the value outside the function doesn't change. Now let's try the same thing with a list. Wait, why did the original list change? We never returned anything. This happened because lists are mutable objects. Mutable means they can be changed after they are created. Both items and fruits refer to the same list object. When we use items.append mango, we are modifying the existing list object. Since both variables, fruits and items, refer to the same object, the change is visible outside the function as well. Mango got appended in the list. Let's take another mutable example. Dictionaries are also mutable. The function modifies the same dictionary object. So the original dictionary changes. The marks are changed to 95. Generally, immutable objects like integers, floats, strings, and tuples do not change in the caller when you reassign them inside a function. Mutable objects like lists, dictionaries, and sets can change because the function can modify the same object. So remember this simple rule: if the object can be modified, changes made to that object inside the function are visible outside the function. If the object cannot be modified, reassigning the parameter inside the function doesn't affect the original variable. Let's discuss our final practical program. This program combines today's concepts. Students is a mutable list. The function accesses the global variable school. It also modifies the existing list object students. This shows how scope and object references work together. So that's all for this video. Today we learned 3 important Python concepts: variable lifetime, LEGB rule, and pass by reference. How Python manages memory and variables. In the next video, we'll learn about lambda anonymous functions. You'll discover how to create small one-line functions using the lambda keyword. If you found this video helpful, don't forget to like the video, subscribe to the channel, and press the bell icon so you don't miss the next lesson in our Python function series. Thank you for watching, and I'll see you in the next video. Happy coding!